Ang pag-uusapan natin ngayon is the analysis of statically determinate structures. This includes topics such as support connections, idealized structure, tributary loading, principle of superposition, and equations of equilibrium. What is support connections? Structural members are joined together in various ways depending on the intent of the designer. The three types of joints most often specified are the pin connection, the roller support, and the fixed joint. A pin-connected joint and a roller support allow some freedom for slight rotation, whereas a fixed joint allows no relative rotation between the connected members and is consequently more expensive to fabricate. Kung makikita natin dito sa figure natin, yung figure sa left side, this is a bolted connection and this is typical pin supported connection. At dito naman sa right side, we have here a welded connection and this is a typical fixed supported connection. Ito naman kapag reinforced concrete. So here on the left side, this is a typical roller supported connection. And here on the right side, this is a typical fixed supported connection. Idealized model. So ito yung mga symbol na ginagamit natin sa idealization. This is for the pin support and this is for the pin connected joint. This is for the fixed support and for the fixed connected joint. And here, we have here a torsional spring support and torsional spring joint. When selecting a particular model for each support or joint, the engineer must be aware of how the assumptions will affect the actual performance of the member and whether the assumptions are reasonable for the structural design. A beam with a concentrated load P is shown in the figure. So this is our actual beam. And if we are doing the analysis, so we are using the idealized beam in order for us to compute for the reactions. So dito makikita natin, this is a bolted connection. So at point A, this is pin supported. And dito naman sa B, so nakapatong lang yung beam natin dito. And horizontal movement is not restricted. So it is free to move horizontal. Therefore, this is idealized as a roller support. So, minsan, ang ginagamit nating symbol sa roller support ay ganito. In here, the supports for the coplanar structures are shown in the table. So, dito pinapakita yung types of connection, the idealized symbol, and the reactions. For number 1, we have here a light cable or a weightless link. So, ito yung kanyang idealized symbol. And for the reaction, we only have one unknown. And the reaction is a force that acts in the direction of the link or the cable. Number 2, we have here a ruler and a rocker. So, this is a symbol for a roller. At ito yung isang symbol na sinabi ko kanina. And this is for the rocker. For the reaction, we have only one unknown. And the reaction is a force that acts perpendicular to the surface of the point of contact. We have to take note of that. Perpendicular to the point of contact. So halimbawa, meron tayong inclined surface and our structure is supported by a roller support at this point. So sinasabi dun sa definition of the reaction na yung ating reaction must be perpendicular to the surface at the point of contact. So, ibig sabihin, if this is the surface, your reaction here is perpendicular to the surface. No, hindi siya palaging vertical. We have here a smooth contacting surface. Naman yung ating idealized symbol for that. And for the reaction, we have only one unknown. The reaction is a force that acts perpendicular to the surface at the point of contact. The same sa sinabi ko kanina sa number 2. And number 4, we have here a smooth pin connected collar. So this is a symbol for a smooth pin connected collar. And we have only one unknown. The reaction is a force that acts perpendicular to the surface at the point of contact. So the same ito sa ruler, sa rocker, smooth contacting surface, and smooth pin connected collar. For the smooth pin or hinge, this is the idealized symbol. And we have two reactions for this. The reactions are two force components. Ibig sabihin, if we have here our surface, yung isang reaction natin dito is the Fy, and we have here another reaction, Fx. How about naman kung naka-incline din yung surface? So kung naka-incline yung surface, ito naman siya. Ito yung ating Fy, and this is our Fx. Number 6, we have here a slider or a fixed connected collar. So this is the idealized symbol for a slider and a fixed connected collar. Wala to siyang resistance with respect to the vertical movement. So therefore, the reaction here, we have here a force that acts perpendicular to the surface at the point of contact, and we have here a moment. For the fixed support, ito naman yung ating idealized symbol for that. So for the fixed support, we have three reactions. We have the components, the Fx and the Fy, and we have the moment. Idealized structures. In real sense, exact analysis of the structure can never be carried out. Estimates have always to be made of the loadings and strength of materials. Point of application for loadings must be estimated. Models for idealization should be made by the structural engineers so that they can perform a practical force analysis of the members. Makikita natin dito sa figure natin, this is a jib crane and a trolley. For the structural analysis, you can neglect the thickness of the two main members and will assume that the joint at B is fabricated to be rigid. That's why nakikita natin dito that this is idealized as fixed connected joint. Furthermore, the support connection at A can be modeled as a fixed support, and the details of the trolley excluded. So, makikita na natin dito na this is idealized as fixed connected. Thus, the members of the idealized structure are represented by two connected lines, and the load at the hook is represented by a single concentrated force F. Beams and girders are often used to support building floors. In particular, a girder is a main load-carrying element of the floor, whereas the smaller elements having the shorter span and connected to the girders are called the beams. So, if this is the floor framing plan natin, etong mga to, yung members that carries the floor, this is referred to as the beams. At yung beam na kumakarga ng kapwa beam ay tinatawag nating girder. So, this is a beam, and here, this is a girder. Often, the loads that are applied to the beam or girder are transmitted to it by the floor that is supported by the beam or girder. Again, it is important to be able to appropriately idealize the system as a series of models, which can be used to determine to a close approximation the forces acting in the members. Consider, for example, the framing used to support a typical floor slab in the building. Here, the slab is supported by the floor joist located at even intervals, and these in turn are supported by the two side girders AB and CD. So, ito yung mga floor joist natin. And we have here a side girder. Ito si girder AB at itong side naman to ay si girder CD. For analysis, it is reasonable to assume that the joints are pin and or roller connected to the girders, and that the girders are pin and or roller connected to the columns. The top view of the structural framing plan for this system is shown here. So this is the idealized framing plan. At makikita natin dito, in this graphic scheme, notice that the lines representing the joists do not touch the girders, and the lines for the girders do not touch the columns. This symbolizes pin and or roller supported connection. Makikita natin dito na yung mga joists natin ay hindi siya nagtatouch sa ating girder at hindi rin siya nagtouch sa column. So, the same, yung girder natin ay hindi nagtouch sa column at this point, and that point. So, ibig sabihin nito, this is symbolized as pin and or roller supported connections. So, paano naman kapag ang connection natin is fixed connected? So, makikita natin dito sa idealized beam natin na nag-touch yung line natin representing our beam, and it touches the column. So therefore, it is representing a fixed connected support. And then here, it is touching at this point, and that point. So this is a fixed connected support then. If the reinforced concrete construction is used, the beams and girders are represented by the double lines. These systems are generally all fixed connected, and therefore the members are drawn to the supports. So makikita natin dito, itong square na to is representing our floor. And in here, double lines yung ginagamit natin. So itong line na to at itong line na to representing the beam. At sa kabila, itong line na to at itong line na to representing the beam. And here, this is our column, and this is the column, this is a column, and this is a column. Yung beam natin dito touches the column, no? So this represents na this is a fixed connected support. And nakadash to yung mga lines na to because they are below the slab. Structural graphics and idealization for the timber structure are similar to the made of metal. For example, the structural system shown here in the figure represents a beam wall construction, whereby the roof deck is supported by the wood joints, which delivers the load to the masonry wall. The joists can be assumed to be simply supported on the wall, so that the idealized framing plan would be like this in the figure. Tributary loading. When the flat surfaces such as walls, floors, or roofs are supported by a structural frame, it is necessary to determine how the load on these surfaces are transmitted to the various structural elements used for their support. There are generally two ways in which this can be done. The choice depends on the geometry of the structural system, the material from which it is made, and the method of its construction. Ngayon pag-uusapan natin yung one-way system and the two-way system. A slab or deck that is supported such that it delivers its load to the supporting members by one-way action is often referred to as a one-way slab. To illustrate the method of load transmission, consider our framing system shown here in the figure. So kung makikita natin dito, yung beam AB, the beam CD, and the beam EF rest on the girders AE and BF. So kung makikita natin dito, yung beam AB natin, the beam CD, and the beam EF is resting on the girder AE and girder BF. Makikita natin dito that at point A, B, C, D, E, and F, yung mga beams natin is not touching the girder. So, ibig sabihin, this is assumed as pin connected. Paano natin malalaman if we have a one-way slab or a two-way slab? So, for the idealized framing plan shown here, one-way slab action requires the ratio of the L sub 2 to L sub 1 must be greater than or equal to 2, provided that the L sub 2 must be greater than the L sub 1. So, dito sa one-way slab, paghahatian nila yung load. No? So, kung itong slab na to, kalahati ng load ay mapupunta kay beam AB at kalahati ay mapupunta kay beam CD. And in here, kalahati ng load ay mapupunta kay beam CD at kalahati naman ay mapupunta kay beam EF. So, technically, hatian lang to, no? So, para tong sa magkakapatid, hating kapatid, pero lamang ang dalok, no? So, dalawa kasi mapupunta sa kanya. Okay, balikan natin yung figure na pinakita kanina. Let's check if this is one-way or two-way slab. So, titingnan natin sa idealized framing plan natin. Ito yung i-check natin. So, the L sub 2 is equal to 4 meters and the L sub 1 is equal to 2 meters. So, this is the L sub 2 and here, this is our L sub 1. So, the ratio of the L sub 2 to L sub 1 would give you 4 over 2 and that's equal to 2. So, sabi doon kanina that for one-way slab action, it requires the L sub 2 over L sub 1 greater than or equal to 2. So, this is one-way slab. Since this is one-way slab, kalahati ng load ay mapupunta kay AB at kalahati ng load ay mapupunta kay beam CD. Kalahati naman dito ay mapupunta kay beam CD at kalahati dito ay mapupunta kay beam EF. So makikita natin dito that the magnitude of the load na matatanggap ng beam AB natin is just the same with the magnitude of the load na matatanggap ng beam EF. So, if we are going to isolate that, this is true for the beam AB and beam EF. Now, we can say that the loading, yung loading na kakargahin ng beam AB is just equal sa loading na kakargahin ng beam EF. So, si AB na lang yung kukunin natin. Makikita natin dito that the load na kakargahin ng beam AB is a rectangular load or a uniformly distributed load. And it is supported by a pin support here and a ruler support here. So, we assume that this is simply supported kasi the beam AB is not touching the girder here at point A and here at point B. So this is point A and this is point B. Now, since this is a uniformly distributed load, yung gagawin natin ngayon is to compute the magnitude of the UDL, that is W1. Okay, so paano natin malalaman yung magnitude ng distributed load? Makikita natin dito, given yung loading natin that this is 0.5 kilonewton per square meter or this is equal to 0.5 kilo Pascal. So, from the idea of the tributary loading, since kalahati nito, sabi nga kanina, kalahati ay mapupunta kay AB at kalahati ay mapupunta kay CD. So therefore, this distance here ay yung multiplier natin dito sa load natin. So we have W1 is equal to 0.5 kilonewton per square meter multiplied by the distance of 1 meter. Therefore, W1 is equal to 0.5 kilonewton per meter. So this is equal to 0.5 kilonewton per meter. And if we are going to solve this, makikita natin dito that we should have two reactions here, the AY and the reaction AX, and here we have the reaction BY. So since solving for the forces horizontal is equal to 0, wala naman tayong horizontal forces, so therefore that gives you AX is equal to 0. Now, iso-solve natin si AY at si BY. Since this is a uniformly distributed load, so ibig sabihin the resultant of the load will be acting at the midspan. And if the span is 4 meters, so this is 4 meters, therefore the resultant of the load is just equal to the area of the load diagram. It is 0.5 multiplied by 4, so that would give you 2 kilonewton as your resultant. Okay, so if we are going to compute for the reaction at AY and the BY, what we are going to do is we are going to summate moment. So summation of moment at point A is equal to 0, taking the clockwise direction as positive. So 2 kilonewton resultant load will give you a clockwise rotation. So that's positive 2 kilonewton multiplied by the distance, that is 2 meters, and minus by counterclockwise rotation multiplied by the distance of 4 meters, that is equal to 0. So meaning your by is just equal to 1 kilonewton upward. And if we are going to summate forces vertical is equal to 0, taking the upper direction as positive, and that would give you your AY positive minus 2 kilonewton plus BY is equal to 0. But since BY is equal to 1, therefore AY is just equal to 1 kilonewton upward. So for the shortcut, so since this is a uniformly distributed load having the resultant at the midspan, so this is symmetrically loading. Ibig sabihin, itong 2 kilonewton na to ay paghahatian lang ni support AY and BY. So this is equal to 1 kilonewton and this is equal to 1 kilonewton without doing this computation. Okay, so let's proceed with the beam CD. Kung makikita natin dito sa beam CD, yung tributary loading natin, the area or the length to be multiplied dito sa load natin is equal to 2 meters. Kasi yun yung lapad, no, ng floor area na kanyang isusupport. So for the beam CD, ayan. So if this is the beam CD, we assume that this is simply supported. So we have a pin connection on the left support and a roller support on the right side. So this is also a uniformly distributed load. And the magnitude of our load here, W2, is equal to W2 is equal to 0.5 kilonewton per square meter multiplied by the distance. Sabi ko kanina, yung distance, this is 2 meters. So multiplied by 2 meters. Therefore, W2 is equal to 1 kilonewton per meter. So this is equal to 1 kilonewton per meter. Okay, how about the reactions? For the reactions, at point C, of course, we have here the Cy and we have here the Cx. Summation of forces horizontal is equal to 0, so therefore Cx is equal to 0. And this is the dy. Now, kung titingnan natin dito, this is uniformly distributed load and this distance is 4 meters. So it is just the area of the load diagram, 4 times 1. So therefore, that would give you 4 kilonewton resultant of the uniformly distributed load. So sabi ko kanina, paghahatian lang ng dalawang support, Cy and dy, yung load na 4 kilonewton, since this is symmetrically loaded. So the Cy would give us 2 kilonewton upward, and the dy is 2 kilonewton upward. Now, kung titingnan natin dito, yung loading na matatanggap ng girder natin, yung loading na matatanggap ng girder AE natin is just the same with the loading na matatanggap ng girder BF. Kung i-isolate natin yung girder AE natin, and that would give us so, bakit dalawa lang yung support natin? Kung titingnan natin dito, we only have 2 columns. Wala naman tayong column doon sa point C. So, makikita natin dito na we have the column at point A and the column at point E. So, here, this is point A and this is point E. And dito, sa gitna na to, this is the point C. Kung titingnan natin, yung load natin dito sa point A natin ay manggagaling doon kay reaction AY. So this is 1 kilonewton. And for the beam EF, yung reaction natin dito sa point E is just the same with the reaction here at AY. And the reaction here at point F is just the same with the reaction at BY. So therefore, this is also 1 kilonewton. At point C, yung load natin dyan ay manggagaling kay Cy. So the load is 2 kilonewton. So it is a concentrated load 2 kilonewton. The same, ganito rin yung mangyayari sa ating girder BF. So we have here the point B and here the point F. So sa gitna, dito siya mag-a-act yung load natin from the beam CD. Okay, so sa B, na-transfer natin si BY. Si BY which is 1 kilonewton. This is 1 kilonewton. And it is just equal to the Fy, and that is also 1 kilonewton. And the load coming from the point D is this. So, si dy, ita-transfer natin siya sa girder, and this would be equal to 2 kilonewton. How about the two-way system? If L sub 2 is greater than L sub 1 and the support ratio L sub 2 to L sub 1 is less than 2, then the load is assumed to be transferred to the supporting beams and girders in two directions. When this is the case, the slab is referred to as the two-way slab. So dito, makikita natin that the L sub 2 is 4 meters and L sub 1 is 4 meters since they are just equal. So L sub 2 over L sub 1 is equal to 1 and this is less than 2. So meaning this is a two-way slab. So for the idealized framing plan, ang ginagawa natin dito para ma-distribute natin yung loads is we are drawing 45 degrees. So since this is just square, ibig sabihin magkakaroon tayo ng triangular loading equal para kay beam AB, kay beam AC, kay beam CD, and the beam BD. So kung i-consider natin ay si beam CD lang, so therefore this is the loading. We have here a triangular load. Now, kung isosolve natin siya, of course, we have here fixed connection at point C, and we have also a fixed connection at point D since this is concrete. So we have here a triangular load. Ayan. How about the magnitude of the load? So for the magnitude of the load, makikita natin dito that this distance here is equal to 2 meters. So W is equal to 0.5 kilonewton per square meter multiplied by 2 meters. And W is equal to 1 kilonewton per meter. So this is equal to 1 kilonewton per meter. And now, this is the idealized beam. Yung idealized beam na to is the same with the AC, the AB, and the beam BD. How about if we have here a length of 6 meters and a width of 4 meters? So, check muna natin if this is a one-way or two-way slab. So we have the L sub 2 yung mas malaki, that is 6 meters, and the L sub 1 that is equal to 4 meters. The ratio of the L sub 2 to L sub 1 is equal to 6 over 4, and that would give us 1.5. And this 1.5 here, so 1.5 is less than 2. So therefore, this is a two-way slab. So for the two-way slab, ang gagawin lang natin is to take 45 degrees dito and 45 degrees dito. And straight line lang dito. So meaning, yung side na to, AB, will have a trapezoidal load. And the beam CD will also have a trapezoidal load. So yung load na kakargahin ng beam AB is just the same with the load na kakargahin ng beam CD. And the load na kakargahin naman ng beam BD is a triangular load. And that load is just the same with the load na kakargahin din ng beam AC. So, isosolve lang natin isa, si beam AB at saka si beam AC. For the beam AB, we have here a trapezoidal load. this is fixed connected since this is reinforced concrete. So this is now the W. This is beam AB. Ayan. So how about the magnitude of the load W1? So assuming that yung load natin is the same kanina, it's 0.5 kilonewton per square meter, and W1 is equal to 0.5 kilonewton per square meter multiplied by the distance. So makikita natin itong distance na to. This is 2 meters multiplied by 2 meters. So therefore, W1 is equal to 1 kilonewton per meter. So therefore, this is equal to 1 kilonewton per meter. And for the beam AC, so si beam AC is just the same with the beam BD. This is triangular, and this is fixed support, and this is W2. So W2 is just equal to, kailangan nating makompute itong distance na to kasi ito yung gagamitin natin para mag-multiply doon kay 0.5 kilonewton per square meter. Now, since this is 45 degrees, so ibig sabihin, this distance here is just equal to this distance here. So this is also 2 meters. So W2 is equal to 0.5 kilonewton per meter square multiplied by 2 meters, and W2 is equal to 1 kilonewton per meter. So this is 1 kilonewton per meter. Ngayon pag-uusapan naman natin yung load path. The various elements that make up a structure should be designed in such a way that they transmit the primary load acting on the structure to its foundation in the most efficient way possible. Hence, as a first step in any design or analysis of the structure, it is very important to understand how the loads are transmitted through it if damage or collapse of the structure is to be avoided. This description is called a load path, and by visualizing how the loads are transmitted, the engineer can sometimes eliminate unnecessary members, strengthen others, and identify where there may be potential problems. So kung makikita natin dito, yung load path natin is designated by the arrow. Yung floor loading to be transmitted to the beams or the joists, and this load to be transmitted to the girder, and yung mga loads na to will be transmitted to the column and to be transmitted to the spread footing. So what is the principle of superposition? The total displacement or internal loading or stress at a point in a structure subjected to several external loadings can be determined by adding together the displacement or internal loadings caused by each of the external loads acting separately. So if this load P here is acted by the load P1 and the P2, ang sinasabi lang ng principle of superposition, pwede nating ihiwalay si load P1 at si load P2. So yung summation of the effect to be created by the load P1, it will be summed up to the effect of the load P2, and that total will be the total displacement or internal loadings. So halimbawa, we have here a beam. This is simply supported beam, and meron tayong point load dito. So we can say that this is just equal doon sa uniformly distributed load na simply supported beam plus yung effect doon sa simply supported with the load P here. Okay, so kung pinag-uusapan natin dito is displacement, we can say that this is the displacement total, and the displacement or the deflection, if we talk about the deflection, so this is the deflection total, and this is the deflection 1 created by, resulted from the uniformly distributed load. And we have here deflection 2 resulted from the concentrated load. So we could say, sabi ng principle of superposition, that the total displacement or deflection is equal to deflection 1 plus deflection 2 at that point. Now, there are two requirements must be imposed for the principle of superposition to apply. First, the material must behave in a linear elastic manner so that Hooke's law is valid, and therefore the load will be proportional to the displacement. Second, the geometry of the structure must not undergo significant change when the loads are applied. That is, small displacement theory applies. Large displacement will significantly change the position and orientation of the loads. An example would be a cantilevered thin rod subjected to a force at its end, causing it to bend. So pag-uusapan naman natin yung equations of equilibrium. Ito yung topic na to is unang in-introduce natin dun sa statics of rigid bodies. So para ma-attain natin yung conditions of equilibrium, we must satisfy that the summation of the forces horizontal must be equal to 0. The summation of the forces vertical must be equal to 0. The summation of the forces in the z direction is equal to 0. For the moment, we have the summation with respect to the x-axis should be equal to 0. The summation of the moment about the y-axis is equal to 0, and the summation of the moment about the z-axis should be equal to 0 in order for us to attain the condition of equilibrium. And makikita naman natin dito, this is the internal loadings. Itong internal loadings ay pag-uusapan natin sa chapter 4 when we talk about the shear and moment diagram. So, kung ito ay yung isang buong structure and hinati natin siya, so therefore exposing the internal loading, so we have here a shear, and we have here a resisting moment, and we have here the normal force or the actual forces. So kung bakit ito ay opposite in direction, kasi kapag pinagdugtong natin, dapat it should attain the condition of equilibrium. So the shear should be equal to 0, the moment should be equal to 0, and the actual or the normal reaction is equal to 0.